In this video, we are going to talk about design criteria. To be successful, you should have out a sheet of paper and something to write with. Our goals are to define design criteria and design constraints, and develop a list of design criteria for a backpack case study. Let's get into it. Before you can start talking about design criteria, in your engineering project, you need to set up a problem statement. A problem statement sets a broad outline for what a team hopes to accomplish with their design. In the case of designing a new backpack, a potential problem statement could be to create a backpack that can be used for both long-term travel and carrying objects daily. The problem with the problem statement is that it's very broad and leaves a lot of room for interpretation. What may be considered long-term travel for you is different than long-term travel for me. And the objects that you carry daily may be different from the objects I carry daily. That's where design criteria are important. Design criteria are numeric goals that allows an engineering team to measure the success of their design. Often, design criteria are numeric, they have units attached, they reduce ambiguity, and they use either less than, greater than, or between. Rarely, if ever, equals to. Design criteria are also the numeric goals or features that allow an engineering team to measure the success of a design. These are often based on research, prior knowledge, or preliminary measurements. Let's take the backpack as an example. Maybe from research or measurements or surveys of people that take long-term trips, you find that they require, on average, 20 cubic liters of space in their bags. You also find out that short-term trips include holding a laptop. Therefore, if you were going to create some design criteria based on your research, you would say that spaciousness is one of your design criteria. And you define spaciousness by saying that the backpack is able to hold more than 20 cubic liters of material. You also would define design criteria as laptop security. And maybe your objective or criteria would be can be thrown more than 100 times without damaging a laptop. Now that's a pretty ambitious goal, but it's certainly one that you could set for your backpack. Pause the video now and think of 3 more numeric units attached design criteria that could apply to the backpack. Design constraints are specific criteria that if not met would immediately cause the design to fail. In the case of a backpack, because it must always be worn on the back, we can think of some constraints around this. An example would be the straps. A constraint would be that the straps must always stay sewn onto the backpack. If a strap were to rip or come apart from the rest of the backpack, the design would automatically fail. Pause the video now and think of just one more design constraint that could apply to the backpack. As a hint, safety is almost always a design constraint. One other way that engineering teams can come up with design criteria is by decomposing their ideas. Decomposing ideas is separating a large design project into smaller design categories, which allow the engineering team to set more specific design criteria. Some subcategories for our backpack could be internal organization, the straps, external organization, or the material. One example of decomposing ideas could be taking that idea of internal organization, straps, and external organization, and then setting design criteria within each. Perhaps in internal organization, we would say that it holds at least 20 cubic liters of material, but it also must hold a 15-inch laptop securely, separate from any other objects. The straps must always be sewn onto the backpack, but they must also be adjustable for an average adult male ages 18 to 55. For external organization, which we weren't even thinking about before, we could say that it must hold at least 1 water bottle, and it must sit flat on the ground when a force less than 20 newtons is applied to it to prevent it from tipping over. To conclude, in this video, you learned about problem statements, design criteria, design constraints, and how to decompose ideas. Hopefully this information will help you in your own engineering design projects.